Hello, my name is Jordan Wooten and I am a product scientist with CriticalPath. This video will provide an overview of CriticalPath and what makes our tool unique, as well as review general guidelines on how to read trace files, which is necessary for both using CriticalPath and being able to find your own insights from your app. So let's start with the overview of CriticalPath. At the heart of CriticalPath are two main components. The first being our smart instrumentation, where we only instrument what matters to avoid unnecessary noise on the trace file. And then second is our CriticalPath tool. And the CriticalPath tool is a platform for pre-production performance engineering that allows you to understand exactly how your mobile app's code is being executed, highlighting any delays in performance while also relating the code to what the user experiences on their device screen. So next we'll discuss two unique features of CriticalPath that help it stand out. And we also have videos dedicated to each of these features if you want more details. But just as an overview, one of CriticalPath's unique features are its video feature, which helps to easily identify any UI-related performance issues by syncing your trace file to the screen recording of your app captured while the trace file is recording. Thus, any performance lags within your app can be identified both visually on the screen recording and also on the trace file, which highlights any delays in the execution of the app's code. Another unique feature of CriticalPath is its execution path. And as an overview, the execution path highlights the progression of calls that are made leading up to a certain process or result within the app. The execution path highlights the dependencies and delays in execution between the various functions, which is crucial in identifying performance bottlenecks. So now that we've discussed CriticalPath, the last portion of this video is dedicated to reviewing general guidelines and best practices when analyzing a trace file using CriticalPath. It's important to understand the basics of how to read a trace file, as well as the terminology that's associated with that, if this is something that you are not already familiar with. So for starters, the first term to know is a slice. And all of these different colored sections on the trace are slices. So this choreographer do frame is a slice, this transversal is a slice, this dispatch task is a slice. All of those are examples of slices. And slices represent a function from the code or a process. And the length of a slice represents the amount of time it took to execute that function or process. So for example, here on the trace file, we see this choreographer slice. And if I measure it by holding down Shift and dragging my cursor, I see that the slice took 4.4 milliseconds to execute. On the topic of slices, I also want to point out what a parent slice is. So a parent slice would be the top level slice in a stack. For example, this choreographer is a parent slice and calls or triggers all of the processes in the slices that fall underneath it. So next I want to discuss choreographer slices, which are specific to Android, but choreographer slices are responsible for managing the animations, transitions, and rendering operations on the device screen. So that's why you'll see so many choreographer slices on your Android trace files, because it's responsible for rendering all of the UI elements that we see on the screen. Next, I'll touch on threads. CriticalPath provides visibility across all threads to ensure that all relevant dependencies are being shown. And if you look here, we have a thread section, and each one of these sections as highlighted is a different thread. This is the animator thread, deliver input event thread, the render thread. All of these are different threads, and we also have the main thread here. And the main thread is the home of all of the UI related elements within your app. Next, I'll quickly touch on the execution path just because we have a separate video dedicated. But if I select a slice, that will reveal its execution path. And when reading the execution path, the slice to the right is always triggered or called by the slice to its left. So for example, this Android UI dispatcher was called by this Android UI dispatcher dispatch, which was called or triggered by this deliver input event slice, which is noting some type of user action. So that's how you would read the path from right to left. The function on the right was called by the function on the left. I also want to discuss the frames, and again, we have another video dedicated to the frames, which goes in hand with the video feature and the frame counter. But just as an overview, the frame numbers on the trace file identify which process occurred while a particular frame of the app is being shown. And then last but not least, our network requests. CriticalPath highlights all network request slices with an N and also provides insight into the information that's being fetched based on the URL for the network request. That way, when using CriticalPath, you know exactly what your network requests are fetching and how long it takes for them to execute. And lastly, I want to talk about navigation. There is a lot of navigation involved when reading a trace file, a lot of zooming in and zooming out and moving left and right. And CriticalPath has hotkeys to make life easier when moving through the trace. So by holding down A on your keyboard, you move to the left. If I hold down D, I'll move to the right. W is to zoom in on your keyboard, and then S is to zoom out. So those hotkeys, A, D, W, and S, really help when trying to navigate the trace so you don't have to solely rely on your trackpad. So that concludes this overview about CriticalPath. For more information about CriticalPath or any of its specific features, feel free to check out any of the other videos on our website.